Hello. Nice to meet you. There are two types of free software developers, the one that are famous and people like me. I'm not really famous, to be honest. Free, like in free software, is the capacity for a person like me and others to present what they do and not who they are. And I really like it, so thank you, FOSDEM. That's my first thank you of the day. And here is a story. And every nice story, where is my slide? Yay! Every story begins with too much time on your hand and a book. Sorry for the English speaker, but anyway, remember that in mathematics, we don't care about what is written. So you will have mathematics books that is written in French, but all the formula are in English, don't worry, they are translated. So this book is called Lipschutz Linear Algebra, and I was like, oh, fine, it's looking fun, this book. For definition and fun that only me understand. Basically, what my book was saying is that it was a cool project manager. It was saying, I will not tell you how to implement stuff. I will just tell you how it's working, the rules. And then once you implement, once you follow the rules, you have metrics. This one is a little bit capillotracted, as we say in French. And then you've got least surprises. I will come on it later because I love to have least surprising. Shit. You know what I mean. Basically, as you see, we've got associativity, a new element of addition, a neutral element of addition, multiplication, and so on. And I want to point, is it this one? Yeah. I want to point that 1 is not 1. You will see it later. 0 is not 0. Computer int are no integers and real numbers are not floats, but good enough lies made a good enough truth. And I will try to prove it to you with code. We don't know, it can work. So once you've got these rules, you code. So I've coded a kind of unit test that is testing for the basic stuff like a plus b equals b plus a and stuff like that, which is not very interesting. But I was like, why not do it? If we can, we do. So basically, I began with the normal basic type of what? We don't see a thing. Scheiße. So basically, I began with a basic type of Python. There is no way to put it in full screen pour faire F11. F9? Non, pour mettre en full screen. So basically, complex time is following the linear algebra rule. Oh, c'est nice, ça. Yep. Ok, c'est full screen. D'accord.
That's Google.
That's Google. Overscalar. Oh. Contrôle-moins, ça existe, hein? Bon, c'est pas grave. Ah, ça marche pas. So, for fun, I tried the NumPy arrays. They are behaving like they should, well, not like they should. They behave like the theorem of linear algebra saying the floats are doing the same, the ints are doing the same. I was pretty surprised with the decimal. But if the tests are saying no, but it's no. That's the way it is. Complex. I love complex. And list, no, obviously, lists are not following the linear algebra. You can try, but no. Here I'm going to introduce, sorry for the stuff, so if you can go on the internet, you will have the full information. There is a small theorem that I created. I don't think it's a theorem. I don't know what it is. If you take intricated multi-table mappings that are implemented in dict that we all know, you can take a path to a key and transform it into a tuple and its equivalent form. So there is a canonical form of intricated dict that are making them like a dict. So I can reason on one level dict, but in fact I can think of intricated dict, and the other way around is working because it's a bijection. It's an isomorphism. Great stuff, isomorphism. Believe me. Oh, not everybody believes in isomorphism. I will prove it to you later. Don't worry. So, like an obnoxious project manager, the math book is trying to tell me how to do stuff. I can tell you I don't like it. I just prefer when I'm given the rules to check. Anyway, you've got U plus V. U plus V. that is supposed to look like this, and the multiplication by a scalar that is looking like this, and this one is important. You will see I'm going to cheat in the implementation. Yoo-hoo! How do we do an implementation that is very naive, which I am. I'm very naive, in fact. So what I did is I propagated the plus on the right side, like it's written in the books. But since I was at it, I was like, why not use the idea of duck typing? Yes, we're coming to it. Duck typing is a little bit like linear algebra. It quacks like a duck, and it flies like a duck, and it's good like a magret canard. Then it's a duck. And I was like, well, why not use both? At the point where you are, you're trying to do something silly. Be silly to the top. You're never winning anything by doing it with, you know, warm water. You go hot. So what I did is that I overloaded the operator. Since I'm dyslexic and I don't know my right and my left, I have plugged everything on the immediate addition, subtraction, multiplication, division. So it's not very fast, I'm sorry. And then I implemented neg this way so that I'm consistent with the stuff I show you. And well, it was quite easy to do. The stuff you're noting there is that I'm saying that basically you can probably do it in any kind of language, to be honest, at least in Perl. Joke. So, does it pass my own test? Yes. Have you seen? I love it. When you pass your own test, you can be proud. So I did implement, actually I didn't, this code I think I stole it on the internet, and it was made by a Dutch person whose name was Guido from something, I guess. But anyway, it's my code now. It's free software, you know. So now we've got this, which is, I didn't put a joke. Oh. So I've got this, which is, so my multiplication, I forgot to say that there is a little twist in the multiplication. When you're taking A, that is a scalar, and you're multiplying it, you're putting to every leaves. But when you've got a dictionary, like when you've got a vector, when you're adding, if you've got the same key, you're adding the same key side by side. But if the key doesn't exist, I create it. On the other side, when you've got multiplication, it's very complex. You're going to see it when it's going to be working with the IPython notebooks that we don't have because my computer is not showing it. Don't worry, I had a backup plan. Excuse me, I've got to go back. Yes, I've got new rules that I forgot to implement in my test, but I passed it, I checked. So we've got the dot product that I use with the paired rotor that is making the isomorphism. So basically I'm not even talking about 3D geometry, I'm just taking random name of keys for my dict. And when I'm doing my dot product, I've got exactly the result of the Euclidean geometry without even trying to implement the Euclidean geometry. So far it's working for dimensions that are even higher than 3 or 2. I'm too much into geometry, I'm sorry, I love it. Yeah, it was intended to be fun. You have the right to laugh from time to time. It's very hard to be there. Oh, Calimero effect, you don't know, you're not on my side. So, dot product is one step away from distance. Thank you. So this is the definition of apps. No, but distance is the absolute value of u minus v. So, and when, yeah, math puns are assigned, but geometrical puns have acute angle. I tried very hard to make jokes for you. So anyway, so I took a random definition that was in the book and I was like, oh, can it work? You know, you've got this cos theta stuff that I don't really understand what it says, and you just have to pay attention that it should be non-null. But anyway, then you implement it this way. I know people hate the one-liner, but I was a Perl coder, so I've got the right to do it. Once again, we're taking random example, 2 dimensions. It's doing what it's supposed to do. We are checking, and then we're trying with a 3D, 4D vector. It's doing the same thing. And when we're dividing by a null vector, it's doing exactly what it's supposed to do, which is an exception of a division by 0. Yes, it's working. Aren't we proud? We didn't even did a lot of code. Yeah, I'm focusing too much on geometry. I know it already. That's the part where I don't have my... where is Stefan? Oh, I'm deep shit. Normally I'm supposed to show you some code. No, I'm joking. Up. When you know that everything can go wrong, you prepare a backup plan. And the backup plan was to have a... Normally I was supposed to have a... I hope I've got a good memory. Please help me, God, please. Yes. Normally, if I had a IPython notebook, I would have made it, you know, like magic and make stuff appear like a magician. And so how it is. Sorry, I'm coding in Python 2 right now. I'm sorry, I intend to go in Python 3, but right now I'm doing my cider. Here is a normal vector. I've taken globally the example in the name tuple collection of stdlib3 of Python, which is a point and the color space. Nothing new under the sun, it's a classical one. Then, if you check, when you're adding with, I said that 0 is not 0. Look at it. This is not 0. But if you look at it, it's the same. So this should be true, and this should be equal. But it's just we are not in a geometrical space. There is a lot of stuff that are not geometry. We are not living in the world of the little marmots that are, you know, we are in the world of computers. They are working the way they are. This, normally, 0 is equal to -1 + 1 or 1 + -1. It should be true. Yeah, of course, it's killing the joke. So what happened? So when I was saying that integers are not, int are not integers and floats are not real numbers, the computer is not exactly liking the real geometry of the algebra books. You have to live with the fact that the word is imperfect. It's called the hell of the floats, aka I3E 754, which is a norm that is used in electronic to represent the number in memory. And that's the reason why we have got so much bug. It's non-commutative. And non-commutativity is breaking a lot of assumption of a linear algebra. So it's not my fault. It's not Python's fault. It's the fault of IBM. So you've got this unit vector, neutral element of multiplication, I remember it's called. Excuse me, in fact, I was not good at school. So we've got this stuff that when you multiply by itself, it doesn't move. It doesn't move, yes. Then we've got this one. Why did I write this one? Because it's giving the same result. It's another way to write 1. And then, ta-da-da, what is doing this? I'm multiplying itself by itself and I'm dividing it by itself. I still have almost the same result. So actually it's working. The fact of propagating the multiplication to the keys and then just thinking it should work like addition in vectors with a few tricks that I will not dévoiler because it's open source and you cannot read it. It's making that I've got a unit vector, in fact. And A over A is a unit vector and it has a weird shape that you will see later. I'm very proud of this one, which is a conservation. A plus A is equal to 2A. And it's true. It's amazing. Why are my coordinates so conveniently non-null? I saw people noticing it. No, it's a joke. No, no one. You're really not a good public, I'm sorry. You could help me a little bit from time to time. Meow. Yeah, it's not a bug. It's really like it should behave. When you've got a number, you divide by 0, it's making a division by 0 exception. And if you look at it correctly, every number are in fact an implicit one-dimensional vector. My brain is burning on this one, believe me. It's not too tough. I'm really sorry. Since I used to solve equations without posing them because I was doing something called physics and not mathematics, I used to be working with intuition. The important part is, can we build an intuition of what this stuff would be meaning? The fact that A plus 0 is equal to A, giving that we are calling plus a translation, it's meaning that if you move yourself from nothing, you will not move. Same thing is going with the multiplication by 1. If you stretch yourself from your own size, it's not going to change. And here I wanted to show you what is a unit vector. It has more than, because of the definition I made of the multiplication, and I say that I don't like project manager telling me how to do stuff as long as I'm having the theorems that are being respected. I mean, my stuff are working, so obviously it's a project manager that is wrong, not me. So my multiplication is giving results that are pretty interesting, is that we've got the unit vector by dividing the vector by itself, which is going in every direction, but it's also this and this. And you will see that maybe it has maybe it's not totally stupid. Maybe. This is well known. It's addition and multiplication should be related by this. It's very important that you have to understand that when you're multiplying something by a scalar, you're changing the direction. The scalar is the direction or the number of times of the vector. So when you're going in your direction and then going back from your direction, you're going back to where you were. So it's pretty having an intuition that plus and homothesia are working. Excuse me, I'm scared. How much minute do I have? Thank you. I'm rushing to leave you 5 minutes. So this is a translation of 1. And I'm applying only on P. And it's working like it should. X is equal to 2, Y to 2, and Z to 2. So kind of multiplying in my context with this is kind of saying that we are subselecting the dict. And this dict is looking like a vector. So this multi-table mappings to be honest, because I didn't use for the implementation as traits, I never used the word dict. I'm using mutable mappings. It's duck typing, it's just a stuff with square bracket, items, iter, len, and stuff like that. It's not actually dict I'm using. You could do it with other stuff. So it's a kind of subselection of a space that could be in a space, and I remember that I had a stuff in my book saying that maybe it's a subvectorial space. I really don't like maths, seriously. I love to implement them, but the rest is not funny. Just because I could, I went on the internet and took a random formula, this one, and I decided to implement it to see if it's working. So I made a word counter, which is the normal way of for people that are doing text indexation to represent the text, and I decided without any bias to give me point, to give how much of anything it would be. And then I tried to see if the direction of my topic with Python FOSDEM was working. And also cosine, it's for knowing if two vectors are pointing in the same direction. And cosine similarity, it's in the case you've got base that is infinite, and sometimes maybe it's important to know about the ones that are there and not there. I'll go on the Wikipedia page. I don't understand it, but there was a nice formula, so I used it, and I've got the intuition that I'm right. So basically, what is the direction of FOSDEM, Python FOSDEM, and this thing? Yes, PEP 8. I don't respect PEP 8 all the time. So basically, the results are that concerning this topic, I'm a little bit off topic, but concerning FOSDEM, I'm totally in topic, which is, I'm very proud of myself. Sorry, Stefan. So is there a trick to algebra is non-algebraic type? I don't have a lot of time. I can go back on it later one day. But I thought of it. It's possible. There are times where you cannot define plus, but in the context of a distance, you can define minus to know how far an object is from another object, or a dict, excuse me, a dict. Whew. Oh, thank you. In fact, I had another backup plan. I always have a backup plan. I used to be a sysadmin. So, actual use, text indexation. In fact, it's because of my first mission as a chez un marchand de viande that I knew about it. Log parsing, it's special. Dict manipulation, and oh, fuck, another geometrical joke. I hate the class point 2D when you've got your complex type. We eventually have the quaternions that are more efficient for doing rotation. I want to say that I really don't like this. I like the 2D point class as much as I like the hello world example. Yeah, another geometry. Parallelism, you catch it? No. So, when you've got a dict, you can add it mutable mapping, like beaker cache and dogpile cache are putting the region like a dict, but in fact they are not dict. It's just an abstraction, it's a view. A mutable mapping doesn't have to be a real mutable mapping. Nothing prevents you from taking the keys, shard them on the hash, and then send it to another computer. If the network is always working and stuff like that, it will work. It will do parallelism. And since every key is a distinct dimension, it's without side effect. So you can do it. So it's, I mean, what I'm doing is very nice, guys. Well, should you use my library? Yeah, we are going near to the question and answer. Basically, I'm doing bagel and cider right now. I'm a little bit overwhelmed with time. I will push the modifications that I saw. And the last time I tried to make my module pass the Python 3 was a long time ago when it was a pain. And I will make some effort for you. I've got an Ivor library which has a lot more funny stuff in it, but I don't encourage it. I'm using archery right now. The naming is a pain. The puns are not a good idea. Don't use my convention for naming stuff. It's really not a good idea. I'm a bad coder on this one. Yes, I've got a lot of mad scientist project, because when you've got 2 dimension and vectors, you can build matrix. I already did it, but it's non-commutative, so I'm not in peace with myself. The other algebra I like. I would like to work with the commutator algebra because we've got the float problem, and I would like to know how much we are making mistakes when we are using some stuff like floats. The close to operators that we could implement on objects, so that we could always know we've got profile, like psychometric profile, or if I'm Donald Trump and I want to know about people. If people are matching a profile, I know it's very utopian use of computers. No, I'm joking, much more for in medicine. You can use it to know if people are going to have a disease or not. You can also use computer for good stuff, you know. And there is a set algebra that can be implemented in the same fashion. I've been working on it a little bit. Yes, I'm very bad at communicating ideas. I proposed it to Python ideas. It was a flop. And it's because my communication skills are below average. And that's when we are coming to the... Yeah, really, if you're not laughing, I'm not really doing my job correctly. So, a lot of thanks to Stefan, a lot of thanks to Pierre Parizeau, who learned me about text indexation. All the guys at FOSDEM, I'm very glad that you're there. It's really putting a lot of balm in my heart. The guy who did the Impress stuff, because it's not me who is doing this kind of stuff in JavaScript. And McGraw-Hill for making this book, which was cheap, and Oreilly publication. They didn't give me anything, but I love them, so I don't have. And so normally it's... Do I have time for any questions? How much? Not a lot? So, did I annoy you? Did I bother you? Do you have any question? Are you happy in life?
No? No. Okay, I have one question. Who wants a beer? The bar just opened. Open the door. I think that you will come back because we have another speaker. But please, you can go. That's free. Really free. As in free beer. Okay? And the first one is just for you.
Merci, Stéphane.